Okay, this is 12.1, congruent angles and parallel lines. So then basically what it's saying is that when you have two lines and they're cut by some line like that, it's called a transversal, then there are a bunch of relationships that are created. So these are the names for those relationships. So if you have on this side, so that line, we have the right side of this line L and the left side. So right side, left side. Then we have above these lines and below those lines. We have the interior angles, meaning that they're inside the thing. And then we have these exterior angles. So we have interior angles are 3, 4, 5, and 6. Exterior are 1, 2, 7, and 8. So here we go. Corresponding angles would mean that 3, so 3 is below and to the right of n. 7 is the corresponding angle to that. Or 4 and 8 are corresponding, 1 and 5 are corresponding, and 2 and 6 are corresponding. Then we have alternate interior angles. So 4 and 5 are alternate interior. 3 and 5 are, and 4 and 6 are. Or alternate exterior would mean 1 and 7 or 2 and 8. So that we talked about all those things. Then we have corresponding angles, interior angles. So now this is the trick, is if they're parallel, then all of those things are congruent. So all the corresponding ones are congruent, and all the exterior ones, all the alternate interior ones are congruent, and all the alternate exterior ones are congruent. Specifically, let me give you another thing. All of the obtuse angles are all congruent, all of them, and all of the acute ones are all congruent, but it doesn't necessarily say that in any theorems. Just wanted to give you a heads up. So we have corresponding angles, alternate interior angles, and alternate exterior angles. So there are a total of 8 relationships that we talked about with this. Then we have rigid transformations that prove those. We have proofs. I'm not going to do those because I don't want them. So lines M and N are going to be cut by a transversal. So it says angles 1 and 3 are congruent as vertical. Oh wait, which intricate statements that we should be used to prove that angles 1 and 7. So we have 1 and 3, and then it talks about 3 and 7 are corresponding angles. That actually looks really good. I like that answer. Let me just check the other ones. 1 and 3 are vertical. 3 and 6 form a linear pair. So 3 and 6 do not form a linear pair. They are supplemental, but they do not form a linear pair. 1 and 2 form a linear pair. Okay. 2 and 6 are corresponding, but that doesn't really help us know anything about 7, so it's not going to help us there. 7 and 8 form a linear pair. That's true. 8 and 4 are congruent because they're corresponding, but it doesn't help with angle 1, so not that one. Okay, which of the following use the following figure. So we have this one. You're going to do a proof. First reason is always given. 1 and 3 are vertical angles. That's definition of vertical angles. And then that would be definition of congruence. Definition of transitive property. Definition of vertical angles. Vertical angles theorem says that they're congruent. Okay, 1 and 5 are corresponding angles. That is definition of corresponding angles. And then it would be the corresponding angles theorem, something like that. Corresponding angles postulate. Okay, so let's see. We said, so then we would substitute that in. So it would be the transitive property. Substituting in. So it's saying that 1 and 3 are vertical angles. Then it says that 1 and 5 are corresponding angles. And then since 1 is congruent to 3 and 1 is congruent to 5, then 3 must be congruent to 5. Cool. So that would be by transitive. Okay. Submit that. That is 12.1. Then 12.2 goes here. And it's supplementary angles and parallel lines. Oh, I had wanted me to finish that one, huh? I guess I have to go back. Oh, gosh. Aha, like this. So supplementary angles and parallel lines. So supplementary angles mean that they add up to 180. And with that, it would be the same side interior. So again, those are the interior, those are the exterior. If they're on the same side, what it's saying, and these are parallel lines, they add up to 180. So that's the same side interior and exterior angles theorem. So they add up to 180. So that's what we're using. M and N are lines cut by a transversal. So we want to prove that 1 and 8 are supplementary. Well, we can see that they are same side exterior, but that's not what we want. Angles 1 and 3 are vertical angles. Okay. 2 and 4 are congruent as well as vertical. Are congruent vertical angles, not telling us anything about 8, so not going to help us. 8 and 7 form a linear pair. Okay. 7 and 3 are corresponding angles. That's okay, but it doesn't talk about angle 1, so not going to help us. 1 and 4 form a linear pair, and 4 and 8 are corresponding. That would work. Let's just check this one. 8 and 6 are vertical. 1 and 3 are vertical, but it doesn't say anything about the relationship between 3 and 6, so that would have to be it. Then prove this. Always starts with given. 3 and 6, same side interior. That is just definition of same side interior. So they're supplementary, so that would be the same side interior angles theorem. So that means that they add up to 180. That would be definition of supplementary. Dun, da, da, da. Okay, so that was that one. And then I have to do something funny with this one. So we need to go to here. There we want that one. Oh, this one is what we want. Okay, 12.3 is on proving lines are parallel. So basically what it's saying that if two lines are cut by a so if corresponding angles are congruent, the lines are parallel. The next one says if the alternate interior angles are congruent, then the lines are parallel. If alternate exterior angles are congruent, the lines are parallel. If same side interior angles or same side exterior angles are congruent or supplementary, then the lines are parallel. So that's what it's doing. M and N cut by a transversal. Which angle pair relationships should be used to prove that they're parallel? So let's see, 1 and 6. Those are not anything like that. They're not alternate interior. 3 and 6. Those are supplemental same side interior. That would work. 4 and 5, same side interior, not that. 6 and 7, linear pair, but that doesn't show that they're parallel. So, okay. And then proof, always given. Okay, 3 and 5 are alternate interior angles. That would be just definition of alternate interior angles. And then it's the converse of that. That means that they are parallel. All right. Last thing is the checkpoint. And to do that one, let's see, I want to go to the checkpoint. I don't know if I can. Can I? Let's check. Oh, good. I have to do a construction. So I'm going to do next. And the construction was excused. So we're just going to keep on pushing next through here until it gets unexcused, I guess you could say. Notice I'm just going to keep on pushing next. Oh, it says I'm supposed to do checkpoint 12. That's what I'm trying to do. I'm going to have to edit that part. Okay, checkpoint 12. Here we go. So M and N are cut by a transversal. So what can we use to prove that they're parallel? So 3 and 6 are congruent same side interior. 4 and 6 are supplementary. They're not congruent. Ooh, they're not. They are supplementary. No, they're not supplementary either. 1 and 5 are congruent corresponding. That would work. 2 and 8 are congruent alternate exterior. So look at that. They're trying to stump us with congruent and supplementary. Sneaky people. Okay, M and N are lines, parallel lines cut by a transversal. Which ones should be used to prove that 1 and 6 are supplementary? So 1 and 6 are supplementary. Ooh, okay. So 1 and 2 form a linear pair, and 2 and 6 are corresponding. That actually, congruent is corresponding. That's actually good. 1 and 5 are corresponding. 5 and 7 are vertical. Doesn't help us with 6, though, so that's not helping. We'd have to keep on going. 6 and 2 are corresponding. And so 2 and 6 are corresponding. And 2 and 4 are vertical. Doesn't help us again with 1, angle 1. And 6 and 7 form a linear pair. That's true. 5 and 7 are vertical. That's true, but it doesn't help us with 1. So it has to be the one that we were on. And then use the following figure to information to complete the proof. Always, always given. 4 and 5 are supplementary angles. That is the definition of same side interior. And then 4 and 5 are same side. Wait. Are supplementary angles. Maybe definition of same side interior. Then supplementary. This is a weird one. I don't like this one. And that would be the converse. I don't like that. It is the definition of our supplementary angles. Definition of same side. Definition of, I'm going to go with this. Supplementary, same side interior, same side interior. But this is weird. So which number is that one? 3. I know if it goes wrong, that's where it went wrong. M and N are parallel lines cut by transversal L. So which answer statements can be used to prove that 2 and 8 are congruent? Again, we have to have things that have to do with 2 and 8. So 8 and 7 form a linear pair. That's true. And 7 and 2 are corresponding. That's actually linear pair and then corresponding. And we want to talk about them being congruent. So 8 and 7, 2 and 8. Nope, that doesn't help us do that. They're congruent. So 2 and 4 are congruent vertical. Good. 4 and 8 are congruent as corresponding. That's a good one because we talked about those being congruent. And we talked about 4 and 8 being congruent. So then therefore those two will have to be congruent. I'm just going to stick with that one. I like it. Let's look at that number 3. Did it work out? It did. Okay, good. So that was the end of 12.